Okay, previously we had talked about a sequence, which is just a list of numbers. Today we're going to start talking about a series, which is just basically an addition of a list of numbers. The two types of series that you have previously covered in pre-calc should be an arithmetic series. An arithmetic series is just a series where the pattern is you are adding the same number every single time. So if you notice in this particular series, you are adding 2 every single time. This is called an arithmetic series. The other type of series that you learned about is what's called a geometric series. That is when you multiply by the same number to get to the next term. So this is a series because you're adding a list of numbers, but it is called a geometric series because every previous number is being multiplied by 2. The first thing we're going to talk about is notation a little bit. This sigma should look familiar from pre-calc. So when I say that sigma n equals 1 to infinity of a sub 1, a sub n, it means that my first term in my series is a sub 1. The sigma symbol means that we are adding a whole bunch of terms, and my counter goes up to infinity. One vocab that you need to know is what's called a partial sum. So if I ask you for the first partial sum, it would just be the first term. If I ask you for the second partial sum, it would be the first 2 terms added, third partial sum, first 3 terms, etc. Okay. What we are most interested in calculus is knowing if a series converges to a value or not. So if I add up an infinite number of things, does that sum converge to a value? And we're going to skip over a couple of these pages for right now and skip all the way over to page 8, and we're going to talk about a geometric series. So if you think about before what I mentioned, a geometric series is a series where you are adding up a list of numbers, but in order to get from the next term from the previous term, you are multiplying by the same number every single time. Notice in this particular case, you're multiplying by 1/2 to get to the next term. That 1/2 is called your ratio, and we're going to call that R. So in this particular example, we call our common ratio is 1/2, which we will call R. If you have a geometric series and if the absolute value of R is greater or equal to 1, there is no way that this sum could possibly converge to a value because those numbers are getting bigger and bigger. However, if the absolute value of that R or that common ratio is less than 1, then the series converges, which means that you can add up all these terms infinitely, and the sum of that series is going to be A, which is your first term, divided by 1 minus R. Also notice how we write out all the series for a geometric. Your first term would be A, your next term would be A times R. The next one is the previous term times R again, which is R squared, etc., till the pattern continues. Please make a note card on this, which is called geometric series. So the question we want to be able to answer is determine whether a geometric series converges and to what value does it converge. So here's my first series. Now if you want, you can go ahead and write out the first couple terms. So the first couple terms of this series would be if I plug in 0, my first term would be 3. If I plug in 1, my next term in my series would be 3/2. If I plug in 2, the next term is 3 squared, 3 over 2 to the third, etc. So this is an infinite series because we're counting up towards infinity. Now if you look at these terms, we can see that my first term, which is called A, is 3. Your common ratio, which we call R, is 1/2 because we are multiplying by 1/2 every time. Once we have these two pieces, I notice that the absolute value of R is less than 1, so I know that this series converges, and it converges to the sum of A over 1 minus R, and if you simplify this, this becomes 6. Now, it is not necessary to write out these terms to pick out these two pieces. I can see clearly the first term will be 3. Your R value is going to be what you're multiplying by every single time, so it's really the number that just gets raised to the nth power. So notice whatever is getting raised to the nth power in this first example is just 1 over 2. In the same way, let's look at this second example. Okay? If I ask you what the first term is, if I plug in 0 for n, the first term is 1. If I ask you what that common ratio is, which is R, instead of writing out all the terms, let's look at this. What's being raised to the nth power is 3 over 2. There's my common ratio, but the absolute value of R is greater than 1, so there is no way that this sum is going to converge, so we say that this series diverges. One example of a geometric series is basically a repeating decimal. So 0.08 repeating is 0.08 plus 0.0008 plus 0.000008 plus etc. If you write this as a fraction, this is really 8 over 100 plus 8 over 10,000 plus ... So this is really a geometric series because what you're doing every single time is multiplying by 1 over 100. Your first term is 8 over 100. If I want to rewrite this in sigma notation, you can either start your sigma at 0 or 1, it doesn't matter. I'm going to start it at 0. So there's my A, there's my R, that's my sigma notation. I know this is going to converge because R is less than 1, the absolute value, so it will converge to whatever A over 1 minus R is, and if you simplify this, this is 8 over 99. If you type in the fraction 8 divided by 99 on your calculator, you will see this is the same as the decimal 0.08 repeating. So repeating decimal is a geometric series. Okay, let's try 2 last examples. Okay, at this time I would go ahead and pause the video, try these 2 on your own, and then come back to check your answers. Okay, the question on these is determine whether the following series or converges. If it converges, then find the sum. First thing I always figure out is what my R value is. I notice in this problem, the 1/2 is being raised to the nth power. My R is 1/2. Absolute value is less than 1, so I know it will converge. So in order to figure out what it converges to, I need to find the first term. This series starts at n equals 4, so my first term is 1/16. So the sum of this series is 1 over 16 over 1 minus 1/2, which simplifies to 1/8. So the sum of this infinite geometric series is 1 over 8. B, same thing. I notice that R is also 1/2, so I know this also converges. But notice this series starts at n equals 0. So my first term will be 1. So this sum is A over 1 minus R, which is 2. And it makes sense, this sum is bigger than this previous sum because you are adding more terms here.